Okay, so like I've told you in chapter 7, we are solving systems of equations, and we've already solved systems of equations by graphing. What's the answer to a system of equations? When we graph, it's an ordered pair, right? We graph two lines to see where those two lines cross. And that ordered pair, that x and y coordinate, was our solution to that system of equations. Well, this is no different, okay? For systems of equations, even by substitution and elimination methods, we're still looking to get an x and a y. We still need an ordered pair, okay? So we're looking for an x solution and a y solution. So keep in mind, we got two equations with two variables. That's why it's called a system. We got 2 and 2, two equations, two variables. And these are linear systems because we only have two. Like I said before, in Algebra 2, you will have 3 equations with 3 variables. And those are fun, but take forever to do. So we're going to use substitution. Now, substitution means you can replace something with something else it's equal to. Okay? For example, if I'm at a ball game and I want to buy a Snickers bar because, come on, Snickers are great. And I don't have a dollar bill in my pocket, but I have 4 quarters. Can I still buy my Snickers bar? Yeah. If I have 10 dimes, can I buy my Snickers bar? Yeah. If I have 20 nickels, can I buy my Snickers bar? Yeah. If I have 100 pennies, can I buy my Snickers bar? They're not going to like me very much, but I could still do it, technically, right? Because those are equivalent amounts. So if they're equal, we can replace one with the other, okay? So, the substitution method. So anything in math, if we know something equals something, we can replace one with the other. That's the concept that you will do all throughout math. So this is a system of equations. One equation says y equals 3x, and the second one says x plus 2y equals negative 21. Now, we don't know a simple number that x equals, but we know something in terms of y or x. Like, for example, here, we know that y equals what? 3x. So every time I see a y, I can also call that y what instead of y? I can call it 3x because y and 3x are equal to each other. Okay? So if y equals 3x, then this x plus 2y right here can be x plus 2 times 3x. Does that make sense? If this y equals this, anytime I see a y, I can put a 3x in its place. So that's what you're going to do, and that's what I'm substituting here. Okay? So y equals 3x, so where this y is down here, I can replace it with a 3x, and that's what I'm going to do. So x plus 2 times 3x equals negative 21. So my parentheses right here is where a y used to be. And I'm replacing one with the other because they're equal to each other. Now, I only have x's now, don't I? Right? Can I solve an equation that only has x's in it? Instead of an x and a y? Can I solve for x now if I only have x's? I can. That's the whole point in substitution, so that you get it to where you only have the same variable in the same equation. That's the whole point. Is to get it to where you have the same variable in the same equation. So we can simplify and solve this. What is 2 times 3x? So x plus 6x equals negative 21. X and 6x are like terms, aren't they? What is x plus 6x? 7x equals negative 21. So how do I solve that for x? Divide by 7, and x equals what? Negative 3. So I've got just a number for x, and so now I have to get just a number for y. How do you think we can do that? Yeah, it says y equals 3 times x, right? And since I know what x is now, I can substitute there. So y equals 3 times negative 3. Because now I know that x equals negative 3. And what is 3 times negative 3? Negative 9. So here's my x. Here's my y. My very last step is to write an ordered pair, x then y. And ordered pairs have parentheses and commas, y'all. They're not just a list of numbers. So this is negative 3, negative 9. That is my answer. So if they were lines and I were solving by graphing, guess what point they would cross at? -3, -9. It's the same thing that we're talking about. It's just doing it in a different way. Okay? Because graphing method does not work well all the time. I mean, sometimes we have really, really, really big numbers, right? And the graphs won't fit on our paper where they intersect. So that's why there's multiple ways to solve a system. So that's what we're doing. We're looking for things that are equal to each other and replacing them. So look at problem B here. X equals 4y and 4x minus y equals 75. So you want to look for a variable that says it equals something. X equals something or y equals something. So does it tell me that x equals something or y equals something? It tells me x equals what? 4y. So anytime I see an x, I can replace it with what? 4y. So in that second equation where they have an x right there, I can plug in 4y. And that's what I'm going to do. So 4 times 4y minus y equals 75. Y'all understand my substitution there? When they had an x, I plugged in a 4y. All right, now I'm down to only having one variable, so I'm going to work it out. What is 4 times 4y? Try again. 16y minus y equals 75. And then like terms over there, what is 16y minus y? 15y equals 75. And then how do I solve it for y? Divide by 15 on each side, and y equals what? 5. So now that I have y, how am I going to find x? Right, x equals 4 times y. So I put that 5 in for y, and what is 4 times 5? 20. So that's one reason I don't want to be graphing that, right? So what is my ordered pair for my solution? 20, 5. X then y always for your answer. It doesn't matter if you find x or y first. Just when your answer, put it in order x then y. Okay? Because that one was easier to find y first, and we plugged in and got our x. All right, so after that, they get a little bit more complicated. Just a little bit for now. To start with, you want to look for a variable that's by itself. It says x equals something or y equals something. So do we know what x or y equals? We know y equals 3x plus 2, whatever x is, right? So y equals 3x plus 2, so I can substitute that in where? For y. So y equals 3x plus 2, so I can substitute 3x plus 2 where I have my y in the second equation. So I'm going to copy everything, x plus 2, and then I'm going to use parentheses to plug in my 3x plus 2, and then finish the rest equals 11. So my parentheses is where the y was, and I replaced it with the 3x plus 2. Any questions about how I substituted? Now, what am I going to have to do here, though? I'm going to have to distribute the 2. Copy the x. What's 2 times 3x? 6x. And what's 2 times 2? 4. Equals 11. These two are like terms. So what is x plus 6x? Plus 4 equals 11. How do I solve that for x? Subtract 4. So 7x equals 7. And then I divide by 7, and x equals what? 1. So I've got x. How am I going to get y? Plug 1 in for x over here where it says y equals. So y equals 3 times 1 plus 2. 3 times 1 is 3. Plus 2 is what? 5. So what's my ordered pair then? 1, 5. Any questions so far? We good? Here's a you try. See if we can do that. I know my bulb is dim today. It says y equals 2x minus 3 and x plus 3y equals 5. If you have your ordered pair for your solution, go ahead and check it with a neighbor. We're doing okay with it? So what did y'all do first? Right, you replace the y with the 2x minus 3, didn't you? So x plus 3 parentheses 2x minus 3 equals 5. Any questions about that part? Then what did you have to do? Distribute. So you had x plus what? And then what? Equals 5. And then what did you do? Like terms. What's x plus 6x? 7x minus 9 equals 5. Then what did you do? What's 9 plus 5? 7x equals 14. And then you divided by 7. And x equals what? 2. So after you got your x, how did you get your y? Plug that in for the x in the top one. So y equals 2 times 2 minus 3, which is 4 minus 3. So y equals what? So what's your ordered pair? 2, 1. Raise your hand if you got 2, 1 for your ordered pair. Any questions? Okay. So those have all been where it said x equals such and such or y equals such and such. So the substitution part was pretty easy. Okay. That's not always the case. All right. It's not always set up x equals this or y equals that. So look at a problem like problem D. And these are both linear equations in standard form. I think we talked about standard form in chapter 5, ax plus by equals c. And these are all in standard form. So it's not saying x equals this or y equals that. But we're still having to use substitution because we haven't learned elimination yet. And on your test for this chapter, it'll be specific on what method it wants you to use. So you have to know all the methods. So if we're using substitution method, we have to pick one of these 4 variables, either one of the x's or one of the y's, to get by itself. Now, if I'm picking which one I'm going to get by itself, it's going to be the one with the less work to get by itself. Now, does anybody have a clue on which one they think would take the less work to get by itself? The x on the top row, right? It doesn't have a coefficient besides 1. 1 is its only coefficient, so it's going to be a lot quicker to get that one by itself. Okay, so I like to draw a box around the original equation so I don't like scribble in that box and mess up my originals. So I'm going to write down that equation where that x is. And then I'm going to get that x by itself. So how do I get that x by itself? Add the 2y. I'm going to stick it on front. 2y minus 6. So after I got the x by itself, now it looks like x equals 2y minus 6. So now it does look like x equals something, right? And I used the first equation to do that. So when I plug in, I need to plug it in for the second equation. So whichever one you didn't just use, that's what you plug into every time, okay? So I used the first, so I need to plug into the second. So I plug it in for which one? It says x equals, right? So I got to plug it in for x. So I'm going to say 4 parentheses. And I'm going to put in my 2y minus 6 using substitution. And then finish the rest of it. Plus 6y equals 4. Does anybody have any questions about what I've done so far? Okay, I know x equals 2y minus 6 from the first equation. So I'll plug that in for x in the second equation. So now what do we do? Distribute. So that's going to be 8y minus 24. And then plus 6y equals 4. Now what? Like terms. Now, y'all, I know they're not squished beside each other, but if they're on the same side of the equal sign, they're like terms. Okay, you just combine them. So what's 8y plus 6y? 14y minus 24 equals 4. Now what do I do to solve for y? Add 24. So 14y equals what? 28. Divide by 14, and y equals 2. And now we just have to find x. How can we get x? Yeah, you can plug it in actually for either any of these. Okay? Or this would probably be the easiest way to do it. Right? Because it says x equals 2 times y minus 6. And quite frankly, if we don't get this part right, we're not going to get anything else right anyway. So you might as well plug it in there anyway. So x equals 4 minus 6. And what's 4 minus 6? So what's my ordered pair with my x and my y? Negative 2, positive 2. And honestly, though, y'all, that's as hard as it gets, is when there's not a variable that's completely by itself to start with and you have to get it by itself. That's as hard as substitution can get. Okay? So we're going to do the same thing on problem E right here. We want to pick a variable to get by itself. And I'm waiting to see what you guys say. Which one do y'all want to get by itself? The top y? Yeah, so technically I'd have to distribute a negative 1. But the y actually looks kind of simpler, though, because it's got that 0. So what do y'all want to go for, the y or the x? Don't matter to me. Raise your hand if you want to do the y. Raise your hand if you want to do the x. Okay, I guess the x's win. But when you're doing your homework, guess what? You can do whatever you want to do. All right, so I'm going to do the x. All right, so how do I get that x by itself? Subtract 3y. I like to stick my variable part on front. So x equals negative 3y minus 56. So where do I put that? Yeah, in the top equation for x. So I'm going to plug it right there. So whatever equation you did not just use, that's the one you need to plug into. So 2 parentheses, negative 3y minus 56 minus y equals 0. Then we've got to distribute. So what's 2 times negative 3y? What's 2 times negative 56? Negative 112 minus y equals 0. Now what? What's negative 6y minus y? Negative 7y minus 112 equals 0. Then what? So negative 7y equals a positive 112. Divide by negative 7. What do we get? 16. Negative 16. Again, I'm glad I'm not graphing. So, how are we going to get x? Yeah, where it says x equals over there, x equals negative 3 times y. We know y is negative 16 now. Minus 56. What's negative 3 times negative 16? A negative times a negative is a positive 48. Minus 56 is what? Negative 8. So put my x and y together as an ordered pair. What do we have? Very good. Any questions? Seriously, y'all, as hard as it gets. Are y'all good? Y'all need to say one more like that. Okay, we'll skip that. You try this one, then I'm going to show you one more. And then we'll call it the end of notes. Sound good? I hope y'all get the y by itself on top. If you have an ordered pair, check it with a neighbor, please. All right, so I'm assuming everybody saw for that y in the first equation. Am I correct in assuming that? Okay. So how did you get that y by itself? Okay. So you just subtracted 4x on both sides. So you got y equals negative 4x plus 12. If you put 12 minus 4x, it's the same thing and it'll work. I just like to do the variable first because that's slope-intercept form and we're familiar with that. So then what do you do after you get y by itself? Plug it in for y in the second equation, right? So negative 2x minus 3 times negative 4x plus 12 equals 14. Now we got to be careful distributing that negative 3, right? Hopefully y'all did okay. What is negative 3 times negative 4x? Positive 12x. And what's negative 3 times positive 12? Negative 36. So if you miss your signs on these, we're going to miss it. So what's, these are like terms. So what's negative 12x plus, or negative 2x plus 12x? 10x minus 36 equals 14. And then you did what? Add 36. What's 14 plus 36? 50. And then you divide by 10. And you got x equals what? Did everybody get x equals 5? Okay, then how do you get y? Yeah, you can do it over here. It's the simplest way. Y equals negative 4 times 5 plus 12. So y equals negative 20 plus 12. And what's negative 20 plus 12, y'all? Negative 8. So what's the ordered pair here? 5, negative 8. Raise your hand if you got 5, negative 8. Are there any questions? Y'all, if we miss up on one little thing of arithmetic, that's going to throw us all off, right? So be very careful with your arithmetic. Be very careful with your signs, okay? There's one more I want to show you guys just because there's some in the homework like this. And people see these and they're really simple, but they get confused. So I just wanted to do one with you just to make sure there was no confusion on your all's end. And there's two different things I could do because it says x equals and it says y equals, right? Somebody tell me something I can do. You can. So where they have x equals right here, y equals x minus 8. So where they have a y, I can plug in an x minus 8. Does that make sense? Or what else could I have done? Yeah, I could have put negative 3y plus 12 in for x right here. Right? Either way, I think this is a little easier on this one. So where they have a y, I'm going to replace it with x minus 8. So x equals negative 3 parentheses x minus 8 plus 12. And then I have to distribute that. X equals negative 3x plus 24 plus 12. Now, aren't these two over there like terms? What's 24 plus 12? And then I want to get my x's together, so I have to add 3x to both sides. What's x plus 3x? Equals 36. Divide everything by 4. And x equals what? 9. So if x equals 9, how do I get y? Yeah, it says over there y equals x minus 8. So y equals 9 minus 8. So y equals what number? So what's my ordered pair? 9, 1. So that is the end of our lesson on substitution.